Have you ever felt an earthquake? Although they are increasingly common here in Kansas, we don't get to experience them a whole lot. Think back to the last one that we had. What was it like? How did you react? What about the building you were in? Did you worry about that? Did you notice anything strange about your animals? So here's a video of an earthquake occurring in an office building. Notice how the dog jumps up before the actual shaking occurs. So here are a few terms that we want to define here. A fault is any break in the Earth's crust. When you see a break in the Earth's crust, we call that a fault. The location of the fault is called the focus. This can be anywhere at any depth within the crust. So to make things a little bit easier for us to describe, we designate a point on the Earth directly above the focus and call it the epicenter. The energy itself, the vibration of the Earth, is called the earthquake. These vibrations can be detected at any point where a seismograph is set up. A seismograph, sometimes called a seismometer, is an instrument that is used to detect seismic waves. A seismograph is basically a weight that hangs down from a fixed base. When the ground shakes, the weight moves back and forth, and a pin attached to the bottom draws on a rotating drum of paper. The more the ground shakes, the bigger the lines that are drawn. Now, obviously, we have things computerized at this point in time, but the general setup really hasn't changed much. So the picture that comes out is called a seismogram. A seismogram is simply a graph of the activity recorded by a seismograph over time. Note that each of the black lines represents a minute of time. Look at the top left. The first black line represents 8:15. It's a pretty straight line that indicates not much is happening. The next black line down is 8:16. Still not much. The next black line is 8:17. Again, still not much going on. But look there at 8:30. There's definitely a disturbance there. This is the start of an earthquake. The first type of wave detected by a seismograph is a primary wave, or P wave. These are longitudinal waves, just like sound waves, in that they move through solids or liquids in a series of compressions and expansions. These waves are not typically detectable by humans, although, just like the dog in the video, animals are known to be able to sense P waves. On a seismograph, the P wave is distinguished by a change in the background recordings. So let's look at our example again. At 8:30, we can see the change in the vibrations the seismograph is picking up. This is the beginning of the P wave. And look there about 15 seconds later. There's a larger disturbance that is recorded. This is the second wave of energy. Secondary waves move slower than primary waves and typically show up as more distinct vibration after the primary wave. These are often called shear waves in seismology and move in a transverse wave in a perpendicular motion compared to the direction the energy is traveling. Now remember, those transverse waves are the ones that we typically think about in waves with that up and down motion. Interestingly, S waves only travel through solids. And finally, you get to surface waves. While slower to arrive, these are the waves that do the most damage to buildings and structures. There are two types that move in a more complex motion than S and P waves. Rayleigh waves move in an up and down rolling motion similar to ocean waves. If you've ever been on a boat in the middle of a large body of water, this is how you get seasick. Love waves have a side-to-side motion and move the Earth horizontally. So now imagine standing on the boat that is rolling up and down and at the same time moving left to right. Not a stable thing, and you can probably see how these are the waves that do the most damage. So on your worksheet, there are 3 seismograms from a magnitude 4.3 earthquake that occurred in the English Channel on April 28, 2007. You might not be able to read the times very well at the bottom. The first time is 17 hours and 19 minutes. The next time is 17 hours and 20 minutes. And then the last time is 17 hours and 21 minutes. So each of these spaces between here and here and here and here is 1 minute of time.